So let's take a look at some problems involving L'Hopital's rule. And keep in mind this only works with limits, and also this only works if you get 0 over 0 or infinity over infinity with direct substitution. So let's start off with the limit as x approaches 0 of 3 sine x over 2x. So when I direct substitute 0 into the function, I get 3 times sine of 0 over 2 times 0. Sine of 0 is obviously 0, and 3 times 0 is 0, and then 2 times 0 is obviously 0. So I am getting an indeterminate form of 0 over 0, so that's my indicator that I can use L'Hopital's rule. So in order to do that, I'm going to derive the top and derive the bottom. So the derivative of 3 sine x is just 3 cosine x, because the derivative of sine is cosine and 3 is a constant, and the derivative of 2x is just 2. So now what I can do is plug in 0 for x, and I get 3 times cosine of 0 over 2. Cosine of 0 is 1, and 3 times 1 is 3 over 2, which is our final answer. So let's take a look at a little bit more complicated problem here. The limit as x approaches 0 of 8 plus x cubed to the 2/3 minus 16 plus x squared to the half power over 5x. So once again, I'm just going to do direct substitution. So when I plug in 0 for x, I get 8 plus 0 cubed, which is 0, to the 2/3 power, minus 16 plus x squared, which is plus 0 squared, which is 0, to the 1/2 power over 5 times 0. So if I further evaluate it, 8 plus 0 is 8. You get 8 to the 2/3 minus 16 to the 1/2. Just put those in parentheses, over 5 times 0, which is 0. So 8 to the 2/3 is the same thing as saying 8 squared and take the cube root of 8 squared. So 8 squared is 64, and the cube root of 64 is 4, because 4 times 4 times 4 is 64. Let's write 4. 16 to the 1/2 power can be rewritten as the square root of 16. The square root of 16 is 4 again. And we have 0 on the bottom. 4 minus 4 is 0 over 0, and we still get that indeterminate form, which now we can use L'Hopital's rule to evaluate. So now using L'Hopital's, we need to derive the top and the bottom. So since there is a minus here, we can actually separate these two functions. So let's just first take the derivative of 8 plus x cubed to the 2/3. So we'll write that here. 2/3. So in order to do that, this is just a chain rule. So once again, in order to do this, we got to bring the power down, subtract the power by 1, and multiply by the derivative of the inside function. So I'll bring down 2/3 times 8 plus x cubed to the 2/3 minus 1, multiplied by the derivative of the inside function. So the inside function is 8 plus x cubed. The derivative of that is just 3x squared. So to further evaluate this, we get 2/3 times 3x squared times 8 plus x cubed. Well, 2/3 minus 1 is the same thing as saying 2 over 3 minus 3 over 3. So that'll give me negative 1 over 3. And I can see that the 3's cancel here, and so we're left with 2x squared. And since this is a negative exponent, we can actually bring that to the denominator. So 2x squared over 8 plus x cubed to the 1/3 power. So I'm just going to write that up here. 2x squared over 8 plus x cubed to the 1/3 power. So next, let's evaluate the derivative of 16 plus x squared to the 1/2. So once again, this is the same chain rule that we do. where we bring the power down, subtract the power by 1, and multiply by the derivative of the inside function. So we get 1/2 times 16 plus x squared to the 1/2 minus 1, which is just negative 1/2, times u prime. So the inside function is 16 plus x squared, and the derivative of that is just 2x to the first, or 2x. The 2's will cancel, and so we're left with x on the top, or the numerator, and we can make this negative fraction positive by bringing it to the denominator. So we get 16 plus x squared to the 1/2 power. So there's a minus sign here, so we just write the derivative of 8 plus x cubed to the 2/3 minus the derivative of what we got for 16 plus x squared to the 1/2, which is x over 16 plus x squared to the 1/2, divided by all over the derivative of what we have in the denominator. And we have 5x as a derivative, and this one's pretty simple because the derivative of 5x is just 5. So now we can plug in 0 for everything in this evaluated function. So we can do 2 times 0 squared, which is 0, over 8 plus 0 cubed, which is just 8, to the 1/3 power, minus 0 over 16 plus 0 squared, which is 16, to the 1/2 power, all over 5. 2 times 0 is 0, and 8 to the 1/3 is the same thing as the cube root of 8, which is 2, because 2 cubed is 8, minus 0 over 16 to the 1/2. Once again, the square root of 16 is 4, all over 5. 0 over 2 is 0, and 0 over 4 is 0, and 0 minus 0 is 0, over 5, and 0 over 5 is just 0. And that's our final answer.